Hello and welcome to Sudoku. Here is a Sudoku puzzle that was created by Serbian author Jovan Novaković, and this puzzle was featured on an online contest called White Doku. It was in a period of Christmas, and it was a very fun set of puzzles. And this very puzzle was puzzle number 6 out of 12, and it was by far the hardest puzzle in the set. So the rules are the usual Sudoku rules, the usual arrow rules, meaning that in such a circle, the digit is the sum of all other digits along the arrow. And something else is those X symbols are actually Roman numerals, meaning 10. It means that the sum of both digits is 10. And something very important is that all such positions are marked, so there is a converse condition, a negative rule with those sums of 10, and this negative rule has to be used extensively. So where should we begin? Well, those arrows are definitely very long, and you can see that they have to be 9, because those digits have a minimum of 1, 2, and 3, which has a sum of 6. Here we have a minimum of 1 and 2, which makes 9. So the minimum value is 9. So this has to be 9, and it's the same up there. And we get a 1 by the X rule. Now, those need to be 1 and 2, but I can't put 1 here, or it would put a repeated 9 here. So this is 2, this is 1. We get 8, we get a 2 here. Those have to be 1 and 3. And this is 9 or 7. The same happens here. We have 1 and 2 here, but this is not a 1 because of this 9. This wouldn't be a 9, and because of this 1 anyway. So we get a 2 here, an 8 there, a 1 here. Here this is 1, 2, and 3. 1 is not available here. 2 is not available, or it would put an 8 here. So this is a 3, together with 7. Those are 1 and 2, but 2 here would repeat the 8. So this is 1 with 9 here. This is 2 with 8 there. And that's a very good start. But let's not get carried away, I think. There's still a lot of work to do. Let's do some Sudoku first. 2s, there's a 2 here. 8, there's an 8 there, but it can't be next to the 2, so that's an 8. And by Sudoku we get an 8 here. Is there anything else with 8s? Oh, there's something with 2s. We get a 2 here. 8 is not there. It's not next to the 2 because there's no X symbol. So we get 8 here. 2. There has to be a 2 somewhere here, but 2 here would put an 8 there, which is not available. So we get a 2 here, which will be useful for this arrow. Let's have a look at 8s. Yes, there's an 8 in this corner. And there should be an 8 here. And the remaining 8, there's no remaining 8 actually. But there's a 2 somewhere here. And there's a 2 somewhere down there. There should be something with 1s. We have a lot of them already. So there's a 1 here or there. And there's something with 9s. There's a 9 somewhere here. But 9 can't go there because it would put a 1 here. So there's a 9 in one of those 2 positions. And there's something interesting about this, which is that 9 here would put the 1 there, and 9 here would put the 1 down there, because 1 here would require the 9 to be here. In this box, 1 has to be here or there, and I don't think I can rule out any of those possibilities. But something interesting here is that this is the sum of those 3 digits. This is at least 3, this is at least 1, so the minimum sum is 6, and maximum is 7 by plain mathematics. So this is 6 or 7, we get a 4 or a 3 here. And if this were not a 1, it would have a minimum of 3. That would make 3, 2, 3 at least, which is at least 8, but this is less than 8, strictly less. So there's a 1 here, a 9 down there. And we now know that the remaining digit has to be 3 or 4. But 3 is out of the question because it would put a 7 here. That would clash with this one. So it has to be a 4. Now the sum is 7, and this digit is a 3. 4 is not here, but this is a 6. So we have a 4 here or there. And more precisely, this has to be 5 or 7. And by Sudoku, it has to be a 7. And we get a 4-5 pair in the remaining cells. The missing digits here are 4, 5, and 9. And there also has to be a 6 somewhere. I don't see any way of ruling any option out. Something interesting is that this digit is the same as this one. And it won't be 3, it won't be 9. It has to be 4, 5, or 6. And this one is also 4, 5, or 6. This digit won't be 4 or 6. Because if it were 4 or 6, then it would touch the other digit. And there would have an X missing. So this one won't be 4 or 6, it has to be 3 or 5. And this one can't be a 3, so it has to be 4, 5, or 6. And we know there's a 3 in one of those two positions, and this one has to be 3, 4, 5, or 6. But I don't think any of them can be eliminated right now. So this is good for this part. Is there anything with ones down there? Yes, ones are not here. They are not next to the 9, so there's a 1 here, and this is actually a 1-2 pair. This is interesting because now we know there's no 1 here, there's no 1 here. So on this column, 1 has to go here. This row still needs 3 and 5. We get a 3-5 pair here. We still need 3, 5, 6, and 7 here. 6 is not here. So 6 has to go in one of two positions. This is 3, 5, or 7. What else? Oh, that's interesting. This is next to a 1 and a 3, and there's no X on either of those walls, those edges. So we know that this won't be a 7. Well, we already knew that, but this won't be a 9. That's the important part. So this is not a 9. We know that there's no 9 here, so on this row, 9 has to go there. right? So this is no 9. There has to be a 9 here or there. Should we have a look at this? Well, what can this be? This is at least 3. This is at least 2. So this is at least 6. It won't be 8. So it's 6, 7, or 9. What else? Where else can we look? There has to be a 4 and a 5 somewhere here. Not sure that's useful. There has to be a 9 somewhere in one of those two cells. There has to be a 6 somewhere here. So we know that this can't be a 4, because then 4 would be next to a 6 without an X symbol, which is forbidden. Oh, on this column, 9 is not here, it's not here, it's not here, so it has to be here or there. So this won't be a 9. That's interesting, because now this being 6 or 7, we know that this has a minimum of 3, so this has a maximum of 3. So this is either 2 or 3. And let's ponder the options. 6 would need a 3 here and a 2 there. 7 could be with 4 here and 2 there, or 3 and 3. So this is quite restrictive for those digits. Now we are entering the hard part of the puzzle. So is there anything we can remove? Oh, something of interest is that we get a 1, 2, 3 triple here. So what can we do with the missing digits? Where does 1 go? Well, where does 1 go? Oh, in this box. 1's not here, it's not here, it's not next to the 1, so 9 is here, and we get this 9 as well. That's interesting, I guess. There's something about 7. If 7 is here or there, then 3 can't go here, and 3 has to go there, which doesn't seem to be very useful. But 7 could be here, which doesn't seem to be very useful either. Perhaps I should have a look at what goes on here. So 2 and 8, 1 and 9 are impossible for this 10 clue. Or I should have a look at this one. Let's have a look at this one. So it has to be either 3, 7 or 4, 6. 3, 7 would be in this order, and 4, 6 in any order. So the options are 3, 7 this way, 4, 6, 6, 4. Oh, but no, 4 is not available. So that's not an option. Well, what next? If this is a 4, then this won't be a 6. But that doesn't seem to be of much use. There's this. Or I remember there was something hidden in this first row. That's the thing that took me ages to spot. So is this about the positions of 7? Is this about the position of 7? Well, oh yes, 7 can't be here. So there has to be a 7 in one of those two positions. And something interesting is that if 7 is in one of those, then this has to be a 3. No, this has to be a 4. Sorry. If 7 is in one of those two positions, then this has to be a 4, and then this has to be a 7. But if 7 is here, then this has to be a 6, and we get a 2 and a 3. Oh, and in both cases, I think this has to be a 2. Let's have a closer look. If I put a 7 here or there, then 3 is ruled out from this cell, so the sum here has to be 7, and this gets to be a 2, forced by the sum of 7. But on the other end, if 7 is here, then this is a 6, and we're in a minimum scenario, so this has to be a 2, and this has to be a 3, and the common part of these cases is that this is always a 2. And that is the elimination that took me ages. So now we get a lot of information. We get a lot of eliminations. So this is a 7. This now becomes a 9. I get this 9 and this one. And here we have 4, 6, and 7. No, sorry, this 7 makes this a 6. And now we get a 3 up there to complete this arrow. This is no more a 3. This has to be 4, 5, or 6. And 4 can't be next to the 6, so 4 gets down there. We get this 5, and this 4 resolves this. This is a 7. 6 is pushed to the left. This 4 eliminates this possibility, this option. Now, this can only be a 5. 5, 7, this is a 3. We get a 5 down there, and this 3. This is a 4. That's a 6. That's a 5. I get a 5 here, a 4 down there, a 5 here, a 4 into this cell, and this is basically over. That is a 6. 7 has to go here. I get this 4. I get a 6 on top. This 4, 6 pair is disambiguated. This is a 5. Here we get a 7 and a 5. There's a 7 here. 5, 7. Now, this has to be a 7. Those are 4 and 5. There's a 5 here. 5. This now is a 6. I get 4 here, 3 there. And the puzzle did collapse indeed. This hidden deduction about the position of 7 and the fact that this had to be a 2 was absolutely key in solving this puzzle. And it was not easy to spot. I finally remembered that this was the breakthrough. Perhaps there was another breakthrough somewhere, but I think there's a reason this puzzle was the highest pointer in the whole round. Thanks for watching this video, and thanks to Jovan Novaković for his amazing contests. And see you soon on Sudoku.